So what we're going to be building is this device over here, which I've called the analog channel. And this is like an analog style, analog console style EQ device. It's got 3 different bands. We've got a low frequency band with a frequency control, some gain, and a sort of a switchable type. We've got a mid band, a high band, and then some input and output gain with kind of a bit of an analog style distortion or saturation path here that we'll add in to make it sound a little bit analog. And so as we go, you'll sort of see what all of this does. And so again, this is the device that's inside that resource pack that you'll be able to download. So let's start from the absolute basics though. One thing I always like to do when I'm building Max devices is just have like a simple track set up with some material in it. So I've just got some loops here that we'll use throughout to test things. It's always useful just to have something on hand to quickly test out whatever you're working on. So this is just a basic session that I've got set up. But I'm going to start by loading a Max audio effect. So obviously we're in the Max for Live category in Ableton Live. There are 3 different kinds of Max devices we could build: audio effects, instruments, MIDI effects. We're going to be building an audio effect today. I generally find when you're getting started with Max, audio effects are quite approachable. Instruments are definitely the most complex thing to build. MIDI effects can get a little bit complicated depending on what you're building, but audio effects are a really kind of great place to start, I think, and learn some of the sort of fundamental concepts of Max. Okay, so we load in this blank Max audio effect, and that loads up just this default Max audio effect device. And to open this up, we click the Max icon. I'll double click to make that nice and big. So in a brand new Max device, things that we're going to get over here are just some sort of basic starting points. There are all these things that are called comments that just sort of annotate various parts of the patch. I always like to just delete those straight away because we're not actually going to need those. And we have these 2 objects here, which I'll just drag into the middle, called plug in and plug out, which is just passing our audio from the input of the device to the output of the device. So I'll drag that out because we're going to be building sort of in between those there. Now, we're going to be building an EQ device, and an EQ is essentially just a collection of filters. So we're all obviously familiar with filters from synths or the auto filter device in Max for Live. Oh, sorry, in Ableton Live. And obviously, I'm sure we're all familiar with EQs. But an EQ is really just a bunch of filters: high pass filters, band pass filters, low shelf, high shelf, etc. So the first thing that we need to add into this is we're going to create a new Max object. To do that in Max, I just press the N key and that creates a new object, and I can just start typing, and I'm going to type in biquad. So you'll see there, this says a 2-pole 2-0 filter. So if you're familiar with filters, you would have seen things on filters where it says like 12 dB slope, 24 dB slope. Poles refer to the slope of the filter. A single pole is usually 6 dBs of slope. So like a 12 dB slope is going to be a 2-pole filter, for example. And I'll click that to create this biquad object. This is the kind of basic object we're going to be starting with because this allows us to create a simple filter inside of Max. Now, any Max object, hopefully you are familiar with the fact that we've got inputs or inlets up at the top of the device, and you can sort of hover over these to see what each one does, and then outlets at the bottom. And the first thing we need to do is connect this into the signal path. We can see we've got the signal input over here. So I'm going to grab this patch cable, grab the little dot, and patch that in to the signal path. I'm just going to hold Alt and drag to create a copy because we're basically going to be doing exactly the same thing in the left and right channels. So the way this biquad object works is you'll see I have all these inlets that say something about a coefficient. And the way filters work is you can describe the shape of a filter using various different kind of numbers called coefficients. That's a little bit mathy. If you know what you're doing, you can send coefficients into these to define your filter. But fortunately, Max has a device that's going to do a lot of the hard work, or an object rather, that's going to do a lot of the hard work for us called filter graph. So again, just hit N and type filter graph. You can see this is a filter editor. Hit enter to create that. And what you'll immediately see is this gives us a nice kind of visual layout that looks a little bit like a filter we might be used to. And if I hover over this left outlet over here, you can see it says list of filter coefficients. And so I can patch that into the left input of the biquad. I'll do it to both. And this is going to do all the work of generating these filter coefficients for me. So in order to work with this, we need to send some information into this particular object. Now, whenever you're learning about new objects in Max, there's a number of different ways that you can do that. If I right-click on this object, I can go to the help or I can go to the reference file. So the help is always really useful in Max. That opens up this little Max patcher, which is going to give you a basic example of what this kind of looks like. And you can see it's set up into a biquad. So if you're using a new object for the first time, going into the help file and sort of exploring what's going on there is always useful. One thing that we can do with objects in Max is on any of the inlets, you can right click and you get this big old pop-up menu. And this is called sort of, you'll see the object that it's going to create is called an attr UI, like attribute UI. And this is a quick way of accessing various different messages or parameters you can send to an object. So for example, I want to be able to change the mode of this filter that I've got. I've got this thing here that says edit mode. Creates this little object, which I can just expand. And I can click to change the mode of this filter, low pass, high pass, etc. I could right click on this and say edit frequency. That gives me another little object here as well. That lets me edit the frequency. And you can see I can move that filter. So we're going to get rid of this frequency one. We'll leave the mode one for now because it's going to be useful as a reference later on. But we presumably want to be able to control this filter with some kind of parameters and live dials and things like that. If I hop back over to live and we take a look at our reference device, we'll start with this low frequency band and kind of build up along. We've got the low gain control, we've got the low frequency control, and then we've got this sort of toggle that switches between a shelf and a high pass filter. So let's just start by creating those controls. So I'm going to create a new object and say live.dial. A dial is just a sort of simple dial. I'll hold Alt to copy it. And then I'm also going to create live.text. Now, just worth mentioning, in Max, there are Max native objects. So if I were to just type dial, you'll see I get a dial that looks like this. And then there are Ableton Live versions of those objects. So if I type live.dial, I get the dial that we're all used to from Ableton Live. So you can actually use both. But obviously, if we're building Max devices, working with these, or Max Live devices, working with these Ableton dials is pretty useful. And it also, there are a number of kind of benefits to working with these objects that are going to make our life a lot easier when working in Ableton Live. So generally, always recommend to use the live versions of controls. So now I could just try and patch this sort of straight to this dial into here. But if I interact with this, I mean, you can see that's obviously not doing anything in particular because we need to tell this particular object what actually these dials are controlling. And there's certain ways that we need to interact with this object. In fact, before we do that, let's actually just define what these dials are for, because that's going to be very useful for us. Any object that we have in Max, you can select it and go over to the right here and hit this eye, which opens up the inspector panel where we can set various parameters for this particular object. If you can't see all of these things, there's these tabs at the top, basic, layout, recent, all, etc. I generally always have all open, so it just shows you everything you need to see about this control. And to start, we'll scroll all the way down to the bottom because the area that we're interested first is this area that says parameter. This is where we define kind of the range of the dial, the name of the dial, etc. There's a few things that we need to set up to get started. Now, also just to point out as we go, obviously I've built this device in advance and kind of planned out, spent some time planning out where we're going. But a lot of the time when you're building a Max device, you might just be sort of figuring things out as you go. So now I'm going to give this dial a name because I know what it's going to be, but it's obviously totally fine to just leave this as the default name as you're patching. And if you want to just quickly try something out and come back and edit it later, it's totally fine to do that. So for now, I'm going to call this low frequency in the scripting name. So there's three areas that we can give add names to controls or parameters in Max. There's the scripting name, the long name, and the short name. The short name is the simplest one. That's actually what just shows up on the control. So if I type low freq, you can see it shows up on the control. The long name is what shows up in Ableton Live in the automation choosers. So it's obviously a bit too long to fit on the dial, but when you're choosing it from the automation dropdown, you get a nice bit of extra context. Then the scripting name, to be honest, you can mostly just kind of leave that out because this is specifically for certain things in Macs where you are maybe targeting this particular dial using a command and you need to give it a name. I usually just out of sort of habit like to name it based on the long name that I have, just kind of in a lowercase with a underscore between the two words. But that's just something that I do. You don't have to name it in that way. The next thing we have over here is the range of the control. This is going to set the numbers that are displayed on this control. Again, this is something that you can adjust as you go and just experiment with different values. I'm just going to hop over to this device here and remind myself for the low frequency, we've got from 20 hertz all the way up to 500 hertz. So in order to enter the value here, you type your low range and then a space and then your high range. And that sets the minimum and maximum values of the dial. We can set an initial value for the dial. That's going to be the initial value that loads up when you load the device. It's always a good idea to set that. I'm going to just set that to 100 hertz. And then below that, we can also set the unit style, which is what displays after the number on the dial. This doesn't affect anything in terms of how the dial works. It just is purely for display purposes because we want to know this is sending information in hertz to our filter. So we can set it to display hertz. And there's other kind of units that we can use there. Kind of an important thing here that I'll maybe come back to explain a little bit longer is you also have this thing called the exponent. By default, the way a dial works is when you move the dial through the range, it moves linearly. So you can see that like there's a lot of the dial is for kind of the upper part of the dial. But as I get down to those lower numbers, it moves pretty quickly between sort of 20 hertz and 100 hertz. If I wanted to get a bit more resolution in that range, you can add an exponent. And often you'll do this in filter or like frequency controls. And a sort of standard number is 3.33. What that does is that this makes this dial exponential. And what you'll see is, notice how now I have a lot more resolution in that lower range of the dial. I can move between 20 hertz and 30 hertz, and then it kind of scales it exponentially as I get up there. And if you think about a frequency control, you maybe want to have quite a bit more fine control in that lower range of frequencies and maybe less as it gets up into the higher frequencies. So often you're using this sort of exponential value on frequency controls. Cool. So that's this control setup. The next control that we want, if I just go back over, is this gain control, which goes from -24 to 24 dB. Now, one thing that you can do when you're setting up controls in Macs is if you right-click on a control, you have this thing called prototypes. Prototypes are like quick ways of configuring a control. You can see we actually had one for frequency, but I've got one here for gain. And if I select that, you'll see that this dial changes and does a number of things. It's added dB to the end. It's labeled at gain. And if I open up the inspector, it's added a range to that control. So it's just kind of a quick way of giving you a starting point for a dial. And there's a number of different prototypes for different kinds of objects. So it's always worth just right-clicking and seeing what prototypes are available. But we can obviously go in and manipulate this after the fact as well. So I'm going to just name these low gain. And in fact, I want to adjust the range here. I want it to be -24 to +24. And everything else is already kind of configured for me based on that prototype. The last thing I'm going to do here is configure this one, which is going to be my low type, we'll call it. Low type and type. So the short name doesn't actually display on buttons. And we want this to be high shelf and it's a low shelf rather, should I say. Low shelf and a high pass. Now you'll notice if I hit enter, notice how it got rid of the high pass. Because this is a button and it can only have 2 values, it expects to only receive 2 words in here for its values. This range is basically its on and off state. If you want to use a value that has 2 words, you've just got to put it inside inverted commas. So So now I can have low shelf and high pass. And again, this is going to show up, even though we're not seeing it on the control, this is what is going to show up in your automation in live. So it is useful to set these things. I can change the toggle as well. So I could change that to shelf and maybe HP for high pass. We're actually going to come back and use some images for this later. But for now, we're just going to use HP and shelf for our button. Okay, amazing. So these are configured and we're kind of ready to go with that. But now we need to send these messages to this filter graph in a way that it's going to understand. There's a couple different things we need to do here. We actually also need to define like what is the mode of this going to be? Is it a high pass? Is it a low pass? A shelf? And we actually know we want to switch between using this control. If you select an object inside of Max and over on the right-hand side, you click on this reference panel, this is going to show you a lot of information about the kinds of messages that you can send to an object. This filter graph has got a whole lot in there. And some of them are useful for different situations. Again, that's where the help patcher is really useful. But there's a couple things that we are interested in here. The first one, if we sort of go down this list, you see mode says set the filter type. And if I click on that, it gives me a bit of info at the bottom here. It says, in the left inlet, the word mode followed by a number from 0 to 9 sets the current filter type. And you can see I've got all these different numbers. So I could do this with kind of a control if I wanted to, but just to sort of demonstrate this, if I hit M to create a message box and I say mode, and then I also actually need to type, I'm going to type two numbers here. The first number is the filter that I want to target, because remember, I'm going to have multiple filters in here. I'm going to have a low band, a mid band, and a high band. So I need to tell it which filter do I want to set. And then the second one I'm going to type is going to be the actual number of the filter. We can get this from here, this edit mode. Like if I want a high pass, I know it's 2, a low shelf is 6, for example. And I connect this up. Let's make this 6. Oh no, we'll leave it on 2. So if I click on this now, you can see that sets it to a high pass. If I change this to a 6, it sets it to a shelf. So we're going to configure how this works in a moment. For now, we'll just leave it on 2. And now, just to point out that in order to interact with the Max patch as you're editing it, you can either press Command or Control E to lock the patch. You've got this lock icon on the bottom. The shortcut is Command or Control plus E, and then I can click on things. Or like a short way to do it is if the patch is unlocked, you can just hold down Command or Control, and then you can interact with the patch without having to lock the patch. So if ever you see me just kind of clicking on things, I'm usually holding down Command. If I go back to this filter graph, there's another thing that we need to set. And again, this is obviously something that I know, and you just learn what the different messages are when you spend some time with these. We need to use this params message, because you can see this says set filter parameters for the current filter and trigger the output. The word params, when followed by 3 numbers specifying frequency, gain, and Q, sets the filter parameters for the currently selected filter and triggers output. When followed by 4 numbers specifying the filter number, frequency, gain, and Q. This message sets the filter parameters for the filter indicated and causes output. So because we're sending like multiple messages at once here, what I need to do is I need to use this params message. I need to add that in front of these messages to send to the filter. But there's a couple things that we need to do. So first, what I need to do is I need to take all of these messages, I've got these 3 messages here, and actually combine them into one message. And to do that, I'm going to use an object called pack. So pack says output a list, like a list of items, whenever any element changes. So whenever I change any of the controls, it's going to output all of the values. And if I hit spacebar, I can define some arguments. Arguments are just like defaults for an object that are going to set the defaults for this pack object, as well as set how many inlets I want for it. So I want, I actually just need 2 inlets, but actually I want 3 values, because I'm going to have the first one is going to be my frequency. And so I'm going to type 100 because that's going to be the default value, 100. Next is going to be my gain, which actually defaults to 1. And then the last parameter is my Q, or the resonance, which I'm going to default to 0.7. And again, I know this just by looking at the bottom here. I want to send 3 numbers, which is frequency, gain, and Q. So if I now plug these in, and in fact, I'm just going to delete this here because we're not going to need that for now. If I plug these in here, Whenever you're working in Max, the message object is really useful. If I just type M to create a message box, because you can use it to monitor the output of things. If I connect this pack object to this message box, now what you'll see is when I adjust these controls, I get those three values out. The first value, that 100, gets replaced by this frequency control. The second value, the gain, gets replaced by the gain control. And then that last value, 0.7, is just going to remain constant because we're not going to have a resonance control. So that's pretty good. I could connect this now with this pack, but I need to remember use that params message. So anytime I want to add a message in front of something, so if I just add this back, what I'm getting here is I'm just getting a list of numbers. But if you remember that params message, it says it's going to be the word params, then followed by 3 numbers. So I need to add the word params in front of this. A really handy object you use a lot in Max is called prepend. Prepend just adds a message in front of an input. And if I say prepend params, if I stick that in between these here, now what you'll see when I adjust the control, it needs to go into the right inlet of the message box. You can see it says params and gives me all those values. So I can hook this in to the filter and make sure it's in the right mode. There's the gain. Cool. So that's now adjusting that filter. I can get rid of this message box. But what you'll notice is something kind of funky is happening here. When I adjust the gain, notice how it very quickly just sort of disappears or gets quite loud very quickly. And if I set it to the middle, it just disappears completely. There's no filter. The reason for this is because this filter is expecting linear gain. Most objects that we work with in Max work in a linear gain range. And that is, if you think about the way volume works, if I take a particular volume and I multiply it by 2, that doubles the volume. If I multiply it by 0.5, it halves the volume. If I multiply it by 0, it gives me no volume. And this dial over here, you can see that it's giving me out numbers in a much higher range. So 6 dB, and then all the way down to like negative numbers. But actually what I want is I just want this to go in the range of 0 to 1. Because now if I set this to a 0, that disappears. So we have a really useful object in Max called dB2A. Now there's 2 versions of this. We're gonna come back and use the other version later. In Max, you have 2 different kinds of objects. You have a Max object, which is just the kind of default one here. And then you have what are called MSP objects that have this tilde symbol at the end. Max objects process data. Tilde objects or MSP objects process audio. So for now, because we're just working with data, we're going to use the default, the Max version. But you'll see like objects like this biquad has a tilde at the end because it's processing audio. And in fact, anywhere you see these yellow patch cables, that means there's an audio signal running through there. The gray patch cables means it's data. And I can obviously send data into this biquad as well to control different elements of it, but it's mostly processing audio. Cool. So going back to this dB2A, if I hook this into this control here, really handy shortcut in Max is if I have an object and I want to just snap it into the middle of a patch cable, if I hold down Shift and drag it into the middle of the patch cable, it just automatically snaps it in between there. So it's just a really quick little shortcut to get that in there. Now, what you'll notice if I take the output of this control and I adjust this, notice how the number is getting scaled here so that when I've got my gain at 0, I get a 1. And as I turn this down, that multiplier goes lower. So it's automatically converting these dB values into amplitude values. And now we should see that our filter is responding in a much more kind of useful way. So a lot of the time, like on a control, you want to have these dB values because it makes sense to have that in an audio context, but you want to have them work in this kind of linear amplitude way. So you can just use dB2A to convert those. So the last control we need to configure here, this is working pretty well, is we need to set this mode control. Now we want to switch between 2 different modes. We had 6 and 2, if you remember. 6 was the shelf, 2 is the high pass. So what you can actually do with message objects in Max is you can replace one of these arguments with a notation that says $ and then a number. And this is called a replaceable argument. This means that we can send messages into this message box that are going to change what that message actually is, or what it outputs. So just as an example, let's detach this now because it's going to get a bit weird. If I plug this in here and I connect that up, you can see it's replaced that dollar with the value of my frequency control. So we want to be able to replace this with a 2 or a 6, depending on this button over here. But if we look at the button, the way that most, or sorry, not the button, it's a toggle. The way that most toggles work in Macs is they send zeros and ones. So we want to somehow get this to be, instead of 0 and 1, we want it to be 2 and 6. So what we can do is we can use an object in Macs called an if object. If anyone's done any kind of coding before, you'll be familiar with if statements. Ifs basically allow you to say, if something happens, do this. If not, do something else. And the way this object works is first you've got to say if, and then if what. We say if $I1, so if input number 1, or integer input number 1, is equal to 0, because it's going to be the auth. And there's a number of different kind of comparators you can use here. You can do things like greater than or less than. If we want to do equals, we do a double equal sign. If it equals 0, if the input equals 0, then we want to send a 2. Well, actually, we want to send a 6 because our 0 is the shelf. And then we say else. So if it's not a 0, 2. So if it's a 1, give us a 6. If it's a 0, give us a 6. If it's a 1, give us a 2. Now, if I hook this up, we should see, cool, we're getting a 2. There, we're getting a 6. Amazing. Now I can hook this into this mode, and I can hook the mode, sorry, not into that one. I want to hook it into that one. Hook the mode into the filter graph. So just a quick note here in terms of the inlets that I'm using. You'll see if I hover over these message inlets, you'll see that, actually, I do want to set it into the right inlet. No, I want to set it to the left inlet. This one says trigger the message, set changes it. This one says set the message without output. So we actually want to have output because we want to send that message to this here. So I connected to the left input. Now I should see there I'm on my shelf, there I'm on my high pass. So that's pretty cool. I can switch between those two. And if I go over to the shelf mode and I adjust this gain, you can see that's creating a shelf, adjusting the frequency. So that's all working pretty well. So we've got one other kind of thing we maybe want to change here is if I go over to my high pass mode, this gain still applies, but actually within a high pass, we don't really want to have gain. You just want to be able to control the frequency. So maybe what we want to do is we want to disable this gain control when we're in the high pass mode. So controls in Macs have these messages that you can send to them. There's a number of messages you can send to them, but one is called active. And if I say active, and again, I'm going to use this replaceable argument. I say active $1 because I want to get a message from this button here and send it into this control. So if I just hook this up, and now if I click this control, what you'll see is, cool, it's grayed out. When I switch to high pass, it's turned on. Now, actually, this is kind of in the inverse of what I want. So I want when the shelf is on, I want to be able to control the gain. And when the high pass is on, I want the gain to be grayed out. So what I need to do is at the moment, I'm getting a 0 and a 1, but I need to just flip those around so that when I get a 0 from here, I actually get a 1 that goes into the active and vice versa. Really easy way to do that in Macs is using this little object, exclamation point minus, and then I'm going to say 1. In Macs, we have various math objects. So like, for example, I could say +1, and that's just going to add 1 to whatever I send through it, or -1 is going to -1 from whatever I send to it. If you put an exclamation point in front of it, it does it in the opposite order. So instead of minusing 1, it's going to be 1 minus whatever I send through it. So if you think about it, if I've got the value of 1 and I minus 0 from it, I still get 1. If I've got a 1 and I minus 1 from it, I get 0. So it kind of inverts those. So if I plug that in here, and again, we can just always use message boxes to just sort of check this. Now, when that's off, so it's sending a 0, I can hover over the patch cable to see that it's sending a 0. I get a 1, and when it's on, I get a 0. So now I can just take this, patch this into the active, and that's not doing what I want it to. Sort of one last thing that we can do here is I can actually still adjust this gain control, which maybe I want to not even be able to adjust that control when I'm in the high pass mode. So I can also use another message, just called ignore click. I'm going to say $1. And this one actually works in the opposite way to active, the way the active message works. Oops. So I can actually just take the number straight out of there. Let's pull this up. And now if I turn that on, I can't actually even interact with this dial. That ignore click means it ignores the click. And when that's off, I can interact with it. So that's pretty cool. Now, the one other thing we might want to do is when I switch to this high pass, notice how this gain is still being applied. I maybe want to send a 0 gain when this control is in high pass mode. And then I want to send the value of this gain control when it's in the shelf mode. So what I can do is I can send some messages into this gain here. Let's maybe just move some of these across. We'll get some space. Often there's a lot of moving things around as you build in Max to just find some space for yourself. And I'm going to just create a message, which is going to be 1. Just a message 1, so that I can send that in to this gain. And I want to do that only when I am getting a 1 from this. So when this button is sending a 1, because it's in the high pass mode, I want to send a gain of 1, which is going to set this to neutral. And when it's on 0, I want it to send a message to this to send its value over there. So we can use another useful object in Max called sell or select. And you give the select an argument for the value that you want to select. So if I do select 0 and I connect this up, basically the way this works is when this object receives a 0, so it sends a bang out of this object. And in Max, a bang is just a message that says, hey, do your thing, send your message. So basically, when this button is at 0, it goes to the select and sends a bang because it picks up a 0. So I can hook that into this gain control because when this gain control receives a bang, it just sends its value. The right outlet says if the input doesn't match. Inputs if the input doesn't match. So if the input is not 0, send it through. So I'm going to send it to this 1 message. And now what we should see is when I go to high pass, notice how that's sent that gain message of 1, so it's nice and flat. And when I switch back to the shelf, it sends that gain message to the shelf. So often in Max, it's all about just kind of figuring out these little pieces of logic that you want to set up in a patch and how you might kind of wire them up. And part of the reason that we're building this particular device is it happens to have a lot of really useful objects that we use quite a lot in Max. Things like this exclamation point minus object or the select object, active, ignore, click. These are all things that we use quite a lot. So it's really useful to sort of see these and understand how they work. I know that this low filter has also been quite complex. There's a lot of stuff going on here, but I wanted to start with this because this is actually going to be the most complex of our filters. The other two are going to be pretty straightforward. But for the most part, this is now doing exactly what we want. We can switch to a high pass and we can adjust that there, and we can't adjust the gain. I can switch back to a shelf and I can still adjust the frequency and I can adjust the gain. And when I switch back, that is all being applied. You can double click on these to set them back to default. Cool. So that is pretty handy. That's our low frequency band. So the next parts of our patch are actually going to be pretty straightforward. And often this happens in Max where you kind of build a part of your patch that you can very easily reuse in other parts of your patch. So we've actually got a lot of the objects that we want already available to us. So for example, this params control, this mode, pack, a gain control, dB to A, this low frequency control. These are all things that we want to use again for our other frequency bands. So I'm just going to copy those across. Let's just go back to what we have in live. So we're going to build this mid band, which we've got frequency, gain, and Q. And in fact, the high band as well. We've also got high gain, frequency, and this is a Q control, but just with a slightly different control layout. So these are going to be very similar, these two bands that we're going to add now. So I've copied those across. I just need to add one other control for Q. I'm going to just copy this gain control for now. And in fact, if I right click on this, there is a prototype for Q. So that just very quickly sets that to Q. The other thing we'll need to do though, because I've copied these across, is I'll just need to adjust some of the names for these because obviously they're borrowing from our low frequency at the moment. So I can go in here and say, this is going to be mid frequency, mid freak. And we'll obviously need to adjust the range and the initial values of this. So let's just go back and I'll remind myself what I've got set here. So this goes from 100 to 10,000 with an initial of 1,000. Again, this is just something that you can experiment with. And in fact, when you're going through and maybe rebuilding these devices, I'd encourage you to experiment and try your own values for a lot of these controls. So gain is probably going to stay the same. We just need to rename this to mid gain, but actually all the values are probably going to be the same. So that can all stay as it is. And then the Q, we probably just want to add in, it's going to be mid Q, mid Q, and I actually want the initial to be 0.7. So I'm going to change that to be 0.7. Now, I can just patch this Q value into that last one, because if you remember, this was element 3, which is defaulted to 0.7, but now we actually have a Q control. And so I could patch these in, patch in params. The mode control, we don't actually want variable. We just want this to be a peak filter. So this is going to be our mid-band. We're going to have a little peak filter. So if I select this and go back to the reference, go over to mode, I can just see that in the mode message, number 5 is a peak notch. So I don't need a variable value here. I'm just going to make that 5 and click that to set that band. And now, look at that. We've got ourselves a peak notch filter. So that was pretty easy to set up. There's one other thing that we might want to do here is we're going to add another object called load bang. This is, again, a really useful object that you use quite a lot. What this does is it sends a bang, that thing that just says, hey, do your thing, when the patch is loaded. And we're going to hook this up into this mode message just to ensure that when the patch is loaded, send this mode message to the filter graph. Now, if I go back to adjust my low band, we're going to see something weird might start happening is, oh, look at that. This is actually just still adjusting my mid band. I want this to be adjusting my low band. Maybe I click that and, okay, that's adjusting, but now I go over here and now this is adjusting my low band. So the reason for this is because we need to define which filter we actually want to target in this. There's a couple sort of steps that we need to do. The first thing is this filter graph by default only works with one filter band. So we need to select this and go into the inspector. Several sort of objects in Max have things that you can adjust in the inspector. And one of those things for the filter graph is the number of active filters that we have in the filter graph. So by default, it's going to be set to 1, but I'm going to set that to 3 because I know I want to have 3 filter bands here. The other thing that I need to do is on these messages that I've got here, I need to tell this filter graph, hey, what filter is actually being targeted by these messages? So we know we've already got mode and it says 0. And generally in most coding environments, we start at 0. We don't start at 1. So when I want to target the first filter, it's going to be 0. Second filter is going to be 1, etc. So this mode message is going to the first filter. This mode message is also actually going to the first filter, but I don't want that. I want the second filter. So I've got to change that to 1. The other thing that we need to do is we also need to tell these param controls which filter to target, because how does it know where this frequency is meant to go? So we've also got to add in params and then a number to tell it which filter is going to be targeted by that params control. So this is going to be params 1. Now, if I click these just to sort of initialize them, we should see that I've got my low band and I've got a separate mid band that I can adjust. I can still switch that over to a high pass. Cool. So let's actually listen to this filter. We haven't even sort of heard what it sounds like yet. We've just been kind of patching away. I'm going to go over to live and I'll play something here. Let's turn that down for a bit and hop back over to Max. Now, one of the cool things about Max is you can manipulate all of this in real time. I can switch to high pass. Amazing. That's working. So that's pretty cool. Could try my shelf. Nice, that's working. Let's go apply this mid band. Okay, so I'm not really hearing anything with this mid band. So obviously, as you're going through a patch, it's always very useful to just stop and test your patch at various points as you are working. Because now immediately we've sort of discovered here, there's something going on that I'm not actually hearing this second band. It's not kind of functioning at the moment. And the reason for this is because these objects that we've used here to create our filter, this biquad, these are actually only designed to work with one filter at a time. So at the moment, it's just accepting the first filter, which is this low filter. We need to change these to an object called cascade. And you can see the cascade object says a cascaded series of biquad filters. Basically, the cascade object lets us use multiple biquad filters. And we don't actually need to change anything else about our patch. This filter graph can send straight into the cascade, and the cascade automatically will pick up all the different frequency bands. One thing I'm actually also going to do at this point, because I've just realized that I haven't saved the patch, is it's always good to just save your patch fairly early on to make sure you've got everything there. And I'm going to call this analog channel. Cool. Just to make sure we've got that saved. Also, sometimes what you'll notice, it hasn't done it this time, it did it in the workshop that I did on Thursday, is sometimes you're working in a patch and you patch things together and you think this is all correct, all should be working, but it's not quite doing what it's supposed to be. Maybe you're adjusting something and you're not hearing it change, and you're convinced you've got your cascade, you've set up these params, and you're just not hearing it. Sometimes Macs can be a bit funny and just not do the thing that it's supposed to do. And sometimes all you need to do is save your patch. Sometimes you've got to quit and reopen Macs as well. We'll see if that happens somewhere as we're patching, if it just doesn't do what we're expecting it to do. But if ever you run into an instance where something's just not working and you're not sure why it's not working, always try save your patch or actually quit the patch and reload it. If it's still not working, then obviously there might be an issue in your patch. But it's worth just being aware of that, because I know when I was getting started with Macs, there were many times where I was scratching my head for hours and hours why something wasn't working, and all I needed to do was quit and reopen the patch. So just good to be aware of that. Now that we've added this cascade object though, if I go back and try this out, that's working. Awesome. That's all working. So that's pretty cool. Okay, so let's add in our final frequency band here. I'm just going to move all of this across. And it's going to be pretty similar to this band over here. So I'm literally just going to copy all of these. I'll patch them straight in. And now don't forget, I've got to change a couple of these defaults here. I want to send this to filter number 2. The mode, I want this to be a high shelf. So again, if I go over here, go to my reference, click on mode, I can see from these numbers, high shelf is 7. So I've just got to change that mode message to be 7. In fact, one thing that I didn't do on this pack object here is I might want to also just change the default of the pack object. This is not super important, setting those defaults, because when you're using controls for objects, that default value is going to come from live anyway when you load up the device. But I always just like to have it in there just as like a force of habit to ensure that you get those default values in. And then we probably also want to rename all of these, and let's also just find out what values we've got. So the gain is going to be the same. So it's just the frequency control, which goes from 1,500 to 16,000 hertz, the default of 5 kilohertz. So we'll change this to 1,500 to 16,000, default of 1,500, and then change the name. Cool. Gain, we want to change that to be high gain, and that should all be the same. And then this is going to be mid Q. But now, before I actually change these, if you remember in our patch, we actually have a slightly different control here. Now, obviously controls, in terms of the messages that they send out, whether you use a slider or a dial, the end result is always the same, but you have different kinds of controls for different sort of interface layouts. So in this particular layout, I don't really have space for an additional control here, so this sort of slider works quite nicely. So I'm actually going to change this Q. I'll delete that. new, and I'm going to go live.numbox. Live.numbox gives me this number box. And I can actually right click on that and say prototype Q. I'll hook that in. And let's give that a name. It's going to be IQ, Q. And the initial value, we want that to be 0.7. Cool. So that is all set up. So we can test this out now. Oh, I need to send my mode message. I've got to change this to be 2. And I've got to send that mode message. So I just click on it to send it. There we go. I've got my high shelf. Change the frequency of that high shelf. I can change the Q of that shelf. And just always double check that everything else is still working. That's still working fine. Awesome. So that was all pretty straightforward. I've got my, hopefully pretty straightforward. I've got my basic EQ set up here. The next step for this is to start building an interface. Now, what you'll notice is if I save this patch and I go over to live, what I'm seeing in my patch here, I've got this big old wide device, and I can see the insides of the device itself. With Max devices, there are 2 sort of modes that it can be in. There's this edit mode, where we're obviously editing all the things inside the device, but you don't want to see all these extra little objects and messages and things inside your patch. You just want to see the controls. So there's another mode called presentation mode. And by default, Max devices aren't going to have their presentation mode enabled. So if we have no objects selected, we just click in a blank space and you go up to this P icon. It says Show Patcher Inspector. That opens up various parameters for the patcher itself. And if we scroll all the way down to the bottom, there's this one that says Open in Presentation. So we want to make sure that's on. Now, if I save the device and I go back to live, you'll notice I've got nothing inside the device. It's much smaller and there's nothing inside that window. That's because I need to tell Max which objects I want to see in my interface. And to do that, I just select the objects that I want. So I'm going to select all of these and this shelf control. And I right click on them and say Add to Presentation. They'll get this kind of red ring around them. Then I need to click down in the bottom here. There's this little icon that says Presentation Mode, which switches Max into the presentation mode where I can see what my device is going to look like. This black line is obviously the height of the device in live is limited to a certain height. And now I can just move these controls around and start to build a bit of an interface. I'm going to be sort of very rough and quick with these. Maybe we want, how did I have it? I have the gain at the top and the frequency and the Q at the bottom. Let's just drop this in here. And then we also have the gain at the top, Q in the bottom. Now, the other thing you'll notice is in the finished Max patch, I've got these nice big dials. If I go back over to Max, by default, you're going to be in this kind of small dial size. But if I select a dial, and in fact, I'm just going to select all of the dials at once, there's various different display styles. You can even toggle things like, do you want to display the parameter names? Does it want to show the name of that parameter? Do you want to display the value of the parameter? And I can switch between various different parameter display styles. So tiny, for example, panel, looks like that. I quite like large, especially when I'm building sort of like analog style devices. It looks kind of cool to have these nice big knobs. And then I can just sort of position these for now, kind of fairly roughly where I want them. And Max has some basic aligning for me, which is quite handy. Cool. A couple of other things that we can do. If I just save this patch now and go back over, already that's starting to kind of look pretty cool. We've got some different colors for the dial. We've got this nice black panel behind here. We've got this line. We haven't added our input and output controls yet. We'll get to those in a moment. So let's add those in. If I create a new object called panel, panel is just a really useful visual object. It doesn't do anything. It just kind of sits there and gives you this color. By default, it's going to be on top. I can right click and say send to back to put it behind these dials here. I can adjust the size. Set behind the dials. And now I can start to change the color of these dials as well. Now, if I select a parameter, I'll select these two because I want to change those two colors. In the inspector, you can see I've got the section in the middle where I have various colors or elements of that particular object that I can change the color of. I can change quite a lot. So you can be very flexible with the sort of interface of your devices inside of Max. There's lots that you can configure. The thing I want to control or adjust is this control on variant. I can see that it's blue at the moment. Now, there are two ways that you can set the color of a parameter. I can either have it as a fixed color. Maybe I make this like yellow or whatever, where it's always going to be that color. Or I can have what's called dynamic colors. Dynamic colors are based on your theme in Live. So what you'll see is if I go over to Ableton and I go into my preferences and I were to change the theme, let's maybe go to a dark theme. Notice how this text has become white. I go back to my mid-light. Now it's black text. And various other things change based on the theme. The background of this has gone dark. The backgrounds of these have gone dark. What is really important when you're setting the colors of objects in your patch is it's generally recommended to always use these dynamic colors. The reason for this is, let's say I set my text color here. Let's say I'm like, oh, actually, I want my text color to be kind of, I want it to be, I'm going to fix it to be black. I always want it to be black. So let's say I'm going to go and make it black. And I'm going to save this. I'll just quit this Max device for now so we can see it in there. And I'm going to go and change my theme to a dark theme. Oh, it didn't change my text. Let's try that again. If I select these, text color should be black. Save it. It's probably going to need me to reload that device, so let me just reload it. Grab it from my desktop. See if I change the theme. So we've got black. It doesn't seem to want to save my values there, which is kind of interesting. But the point I'm trying to make is if this control was, say, always the text was always black, if I changed to a dark theme and the text was black on a black background, because maybe some of the other elements of the patch are going to change based on the user's theme, then suddenly that text is not going to be visible. So if you're just building devices for yourself and you know that you always use the same theme, it's probably fine to use a fixed color. But if you're building devices that you know are going to be shared with other people, it's generally recommended to use these dynamic colors because other people are going to have different themes, different settings for those themes, and you want to make sure that different elements of your patch are always going to be visible to different people, no matter what theme they have selected. So unless there's very, very specific things where you always want it to be the same color, it's generally recommended to use these dynamic colors. And you do have quite a lot of options here. So for example, if I change the color of this control now, maybe I want to make this yellow. You can see it gives me a list of different kinds of things inside of Live. So for example, like the control needle color, and these all come from the selected theme. So in this particular theme that I have, LCD text icon is yellow. So I'm going to change those dials to be yellow. If I select these over here, I can make this, I'll do LCD handle variant. I'll make those red. And in fact, I'm going to select this one as well and make the numbox triangle red as well. I'll select this panel. The panel, I'm going to make the interior color. I'll also make it dynamic, and I'll say LCD background. We're going to change these in a moment. But generally, what you'll find is there's kind of a fairly standard approach to the way things are colored in Live. I'm going to give you a link that has like a general sort of guide for how to approach interfaces in your devices, but there's generally sort of a way to do it. So for example, this thing like LCD background is there are places in objects where you might want to have this kind of different theme. So you see you've got all these kind of like LCD options for colors. So if I'm using the LCD background, I probably want to also now select these dials because now you'll see I can't see them, and change parameters here as well. For example, maybe the text, I want this to be LCD text icon inactive so that I can actually see that text. The control needle, I'll make it that same one as well. And then maybe the control range off, LCD text icon inactive. So now I can actually see those values against that black background. And when I change my theme, it's going to adapt based on that because I've used dynamic colors. So one thing that you can do while you're working on a device in Max is if I just pull up this Max window so I can see live, you'll see that it's kind of grayed out, and I can see that those colors have actually been applied there. This icon over here is your preview. It's kind of confusingly labeled. It says preview is on, but this kind of preview is grayed out. If I click that, I can now see what that device looks like right inside of live. So the labeling is a bit confusing, but you can always just toggle it on and off. And you can see what that device looks like. And as you adjust things, like if I maybe move some things to position them and hit save, it updates. You can see it's slightly moved that. Or if I update the color of a dial, for example, or change that and save, you can see it's updated. So I can get an idea of what my device is going to look like. In fact, if I go over to live when I'm in this preview mode, I can interact with the device directly inside of live. So that's a good way to kind of test your devices without having to quit Max. You can just go into this preview mode and deal with them right then and there, which is pretty handy. Okay, so we've got our kind of basic layout going here. This panel object, there's the panel object I added. I'm just going to move it because it kind of showed up in the middle there. So the next thing we need to add to our patch is we've got our basic EQ going. This filter graph is doing all the work. We want to add these input and output controls and also this toggle that's going to toggle on or off the analog mode if we want to. So let's do that part. So now we're going to pretty much be dealing with this section of the patch here because we've got our filter that's doing its thing. All of this over here is to do with our filter. Let's start by just adding in some simple input and output gain controls before we add in the kind of analog section. So I'm going to create a new live.dial, and I'm going to use a prototype for gain. And in fact, I'm just going to right away make this a large dial because I know I'm going to want it to be large. And this will be our output gain. So let's do output gain, and on the control, we'll say output. You'll notice here the scripting name is changed to follow the long name. There's this toggle here that you can turn on or off as link to scripting name. I usually just turn that off because I like to have a different name, my scripting name. But again, it's not super important. The range, I want this to, again, be -24 to 24 for my output, and then dB is fine. So in order to adjust gain, we are going to use an object called multiply, and we're going to use multiply tilde, because remember, the tilde objects are our audio objects. If we were just working with like some information from controls and we wanted to multiply it, we'd use the regular multiply object. But when we want to multiply signals, we use this tilde object. And the reason for this is because, again, if you remember back to the beginning, what I said about this linear gain, if I have a particular level, if I multiply it by 1, I get that same level. If I multiply it by 2, I double the level. If I multiply it by 0.5, I get half the level, so on and so forth. So we're basically just multiplying the level of these signals by a number to create our gain. Gain controls are very straightforward to create. Again, I can hold Shift to just snap this right in the signal path over here. Let's drag this plug out wider. And I'll copy that, hold Alt copy, hold Shift to snap it in place. Now, again, remembering that this is sending dB values, but I want linear gain, I'm going to type dB to A and hook that up here and hook this in. Just pull those down. Now, a handy shortcut that you can use to sort of tidy up your patches, we'll get to doing some tidying up in a bit, but if you select the patch chord and you press Command or Control if you're on a PC, plus Shift and Y, it does what's called routing the patch chord. You can also right-click on a patch chord and just say route patch chords, and it does this kind of little neat routing. So it's a very kind of quick way to just neaten up some of your patches by using that Command Shift Y shortcut. I do that all the time. But now we should have a basic output gain control. So let's check this out. Okay, so it's not doing anything. So this might be one of those instances where we've got to quit the patch, reopen it, And there it's working. So you'll see I didn't make any additional changes to the patch. Sometimes you've just got to quit and reopen Max to kind of kick it into gear. One other thing that we can do here that might be useful is you can add default values to these multiply tildes. I just like to, again, it's not necessary, but just as a sort of precaution, I like to add times by 1. And that just sets a default value of that to 1. Cool. So that's pretty straightforward. Let's set up our input gain. We're basically just going to copy this whole thing here. We'll put input over here and change the name to input gain, and input. And we can even just copy these over here because we're just going to put this before the filter. Again, hold shift just to snap that into the cable. Snap it into the cable. Hook these up. Command shift Y. Command shift Y. Nice and neat. And then our input gain should kind of do its thing. So there's one thing that we need to do here that we're probably not actually hearing now. I want to see if I can get it to do this if I use something that's a lot softer. I don't want to blow your ears out. Actually, I'm going to come back to this in a second. There's one other thing that I want to do with this input gain, which is going to make this hopefully a little bit more audible, is ultimately what we're going to do is we're going to add some kind of saturation, analog saturation to this that's going to respond to the input level of the signal. As the signal gets louder, it distorts more like a kind of an analog EQ might do. But we don't want the gain of the inputs to also turn up the volume. We want to be able to just drive this without affecting the volume. We almost want to have like a gain compensated control. In fact, this is going to make a bit more sense if I just add in this saturation first. So we'll really kind of hear what's going on. So in order to do that, I'm going to create a new object called overdrive. So overdrive, there's a number of different ways you can create distortion or saturation in Max, but a really simple way is to use this object called overdrive, which is a soft clipping signal distortion. And the way overdrive works, if I create this overdrive object, just bring this into the middle. So you got your signal input on the left, and you have an input for a control of your drive factor, 1 to 10, so more or less drive. But what you can also do is you can just set a default here, a default argument for the drive factor. And I'm going to set that to 1, because I just want to have that at a consistent level, and then the actual input going into this is going to affect how much drive I get. So I'm going to set that with a default of 1. And I'm going to then stick that in here. And let's copy that and put it in the other channel. Now, what we should hear, if I run this, I'll turn the output down to start and then turn the input up. Awesome. So we can hear that we're getting some distortion as we drive that based on this input signal, the level going into the input. In fact, this is because it's before, because our EQ is before the saturation. EQ changes that we make are also going to go into the saturation, which also sort of adds to this analog vibe. Like maybe I can boost some low end. And I get a nice kind of crunchy, distorted low end on that kick drum. So much like in anything with audio, obviously the signal flow in Max is quite important, because if this overdrive was before that EQ, the changes in gain that I make to my EQ are not going to affect the distortion. So it's useful to have that afterwards. Now, coming back to our input gain, obviously you would have noticed that turning up the input gain to drive it also affects the volume. So I've got to constantly kind of jump between the input gain and the output gain. But what if I want to just have this input gain automatically compensated? So if I turn it up by a certain amount, automatically turn it down by a certain amount at the output. So there's a really easy way to do this. Is what I can do, I'm just going to move everything across a bit, is I can actually just take the inverse of this gain control. And to do that, I'm going to multiply it by -1. So really handy, anytime you want to create an inverse of a value, if you just times it by -1, I use a message box to check this out. Now, when I have +12 on my input, I get -12 there. In fact, what I also want to do is I want to make sure that I add a period here. So in Max and in most coding environments, we have two different kinds of numbers that you can work with. You have integers, which are like round numbers, and then you have floating point numbers, which are numbers with decimals. And a floating point number is always going to have more precision than an integer. So because I had just an integer number, I hadn't added this point. When I send values through this control, even though it's sending out actual floating point numbers, they get converted to integers. So I just need to make sure that I tell Max that I want this to be an integer value. Now, there we go. You can see that I've got what I want. So when I have positive 9.1, I'm getting not exactly -9, but because these controls will kind of round up on the control. So it's actually sending a value of 9.07. The controller just shows 9.1, but I'm getting the inverse. And then all I need to do is I need to just multiply that inverse at the output. So again, I'm just going to copy some of these, maybe make a bit more space for the patch. Can reroute these, just Command-Shift-Y. Make a copy and patch that in over there. Although there's one thing that I forgot to do here is I actually need to take the inverse. I need to convert this value to dB2 to A. So actually, I want to just patch that in there because remember we want to work with this linear gain value. Let's patch that in. And now what we should hear, if I save the patch, put my volume there. And even if I turn this input gain down, you can hear it's not doing anything because it's automatically compensating at the output. But I can drive it, and I get that nice distortion without getting that extra volume. And obviously, I've still got my output gain where I can adjust it manually. That's sort of a really quick and handy way of just automatically gain compensating gain controls by just doing the inverse of that. Now, one thing that we're not actually hearing, I was hoping we were going to hear it, but Max is behaving very well today, is sometimes when you are working with dials in Max, particularly things that control volume, you can often hear clicks and pops when you adjust a control. Like if I was adjusting this control, as you're adjusting it, and particularly if you're doing like quick adjustments, you can hear very small little crackles in the control. I was hoping it would make that so you could hear it, but it's not doing it so well today. The reason for this is because when we are working with these data values and sending them into these MSP objects, these audio objects, audio works at a much faster rate than these controls. And so if you can imagine, the resolution of these data controls is much smaller than the resolution of these audio controls. And so, or these audio values. And so you get these little small clicks in the audio signal as you're adjusting the controls. It has to move between different values. So what we can actually do is we can actually send, we can smooth out these signals before we send them to these audio objects, these MSP objects, and even convert them to what are known as signal rates. So by most of the time, these yellow patch cables are sending audio information, like actual audio information that we hear. But you can also send data down these patch cables. The difference between data down one of these patch cables and data down these patch cables is this data gets sent at audio rate. If you know anything about audio, you've heard things like 44,100 kilohertz. That's how many samples there are in a second. So when I talk about the audio rate, that means that the data going down these patch cables is running at that audio rate, and you get a much smoother signal. So there's some things that we can add to our patch to do this. The first thing we're going to do is we're going to use an object called line. Now, there are actually two line objects. There's just a regular line object if we want to smooth data, but there's also a line object with a tilde if we want to work with audio. I'll start with just the regular line one so you can actually see what it's doing. And I'll hook this into this input control. Let's just have a message here. In order to work with this line object, we need to define a couple things. Basically, what the line object does is if I have two data points, let's say I've got a control that's at -12 and then a control that's at 0. Instead of jumping immediately from one value to the next, which can cause these kind of clicks in the audio, line is going to move smoothly between the two. But in order for the line to work, it needs to know two things. It needs to know what is the value that it's going to jump to and how long must it take to smoothly move between those values. So to do that with a line object, we use a message box. And what we can do is we can use another one of these variable arguments to set what the value is going to be. And then the second number is going to be the time it's going to take to slide in milliseconds. So basically, we're going to replace this first argument with the value that we want. So obviously, that's going to be the value of the control, the value we're going to jump to. And then the second argument here is how many milliseconds is it going to take to jump to that value. So if I hook this into line, now what we should see is if I adjust this control, notice how that number didn't immediately jump to that value. It slowly moves to this value that I want here. At the moment, it's also outputting integers. There's a mode that we could set this line to be that it's going to send out floating points. But we're not actually going to use this line. We're going to use the line tilde because we're going to work at audio rate. You can't monitor audio signals with messages, but it's going to have the same effect. It's going to smooth it. So essentially now this line is smoothing out this volume control. We still need to convert these values to decibels though. It's still giving us these, to linear, sorry. We're still getting these decibel values. So now we can use dB2A again, but if you remember, there's the audio rate version or signal rate version of dB2A. You can see it says here, convert a decibel value to a linear value at signal rate. Does exactly the same thing as the other one, but just does it at signal rate. So I can take this value, let's move this control kind of up over here, and just replace the ones that all these ones that I have here. Send that in there, send that in there. I can do the same thing with this inverted value. I'll just copy all of this, send it in there, and then this is going to go into that one, and this is going to go into that one. And then I can just actually copy this patch and do the same thing with the output control and patch those in. So this is a really kind of handy little useful patch that you can reuse. This just simple sort of line into dB2A to smooth controls out. Sometimes it might be a frequency control, it might be a different control, so you might not use dB2A, but this little patch here with the line and the value going into the line is a really handy way to just quickly smooth out the values of controls so that they don't jump between values quickly. So if ever you are building a Max device and you're adjusting a parameter and you're hearing clicks as you're adjusting that parameter, use this little trick with the line object. Cool. So let's add these controls to our presentation. I'll say add to presentation. Go into my presentation mode. I'm going to put input over here, output over here. And then I'm going to create what's called a live.line. Is again just one of these interface objects that doesn't do anything. It just is useful for creating interfaces. So I can create a line between those two controls. Now I could pull this up and go into preview mode if I want to make sort of fine adjustments to this. I'm not going to spend too much time agonizing over the kind of layout of this, but you'll see how I can use the arrow keys to sort of shift these a little bit. I save and it immediately updates the layout in here. So as you're building layouts, you kind of do that a lot where you just sort of adjust things a little bit and then hit save. What you'll also notice is that the width of the device is automatically defined by the edge of the parameters that are visible in the device. So that's quite useful because it's going to just automatically adjust the width of your device. But you can also set a fixed width for your device if you want. So again, with nothing selected, if I go into the patcher inspector and I scroll all the way down, you'll see I have this fixed initial window location. By default, obviously, the height is going to be 169 because that's just the height that you're limited to here. But this third value, so basically the 0 and 0 is the starting point, starts up here as the X and the Y. And then I've got the height, the width and the height. So the height is 169, but I can type in here any value, let's say 1,000, and I'll save. And you'll see no matter what, my device is going to be fixed to be a width of 1,000. If you put a 0 in here, it's just going to automatically size itself based on the controls that are in there. There's different situations where you want to have fixed initial window location. You can even send messages to adjust that on the fly. Like if you've got a part of your patch that you want to hide and show, you can adjust the width of your patch just right inside of Max, which is pretty handy. So moving on to some other visual changes that we can make in this patch. Personally, I think that the layout and the sort of visual design of a patch can make a big difference in how you interact with a particular patch. So it's something to think about when you're building a device. Obviously, there are the insides of the patch, which are very important because that's going to affect how it sounds. But how you use a patch is very much defined by the kinds of controls you use, the layout that you use, so on and so forth. And it can make a big difference into the kind of quality of a device. So these are important things to think about. And Max does give us quite a bit of flexibility in terms of how we create our layouts. So one thing I wanted to change to make this patch just kind of a bit more visually interesting is instead of having this button say shelf and HP, I want to use some icons. You can see I've got these cool kind of icons over here. If you remember, I created a live.text object, which is basically again, there's a number of different ways that you can send the same message. We have live.toggle, which is just an on and off switch. Live.text is also just an on and off switch, but it has this little text display where you can show values on the control. So they do the same thing, but just visually, they're going to give you different results. One of the benefits of live.text is if I select this and I scroll down, you'll see I have this option to use pictures. So by default, the labels are just going to come from the text off and text on label. If I select use pictures, you'll see it goes blank, so I haven't added any pictures in here. And I can add icons or images to the different states of this device. Now, you need to work with something called SVG images. So I've got a couple here that I've created, which we're going to use for some of these. There are a number of different programs that you can use that create SVG files. There is a website called the Noun Project, which is an icon library. There's a number of websites that are icon libraries, but you can find icons in here. This is just a cassette icon that I found, and you can download them as SVG files to use in your Max patches. And you can see there's all kinds of icons that you can find here, or you can make your own. So we're going to use some icons that I've made for this purpose. These are included in that resource pack, which you will get, by the way. So if you want to build this device completely in its entirety, there's some SVG icons you can use in there. Now, in order to do this, I've got two image files. There's obviously an image for the off state and an image for the on state. I need to get the file path of these. On Mac, there's a really handy shortcut. You can press Command, Alt, and C, copies the file path. I'm sure there's probably an equivalent shortcut on PC, but one easy way to get the file path of this is you can actually just drag an SVG file directly into Max, and it loads it up as something called an FPIC. An FPIC is just a static image. So you can actually load JPEGs, you can load PNG files in here. If you wanted to just have like an image as part of your patch, you can just drag it in and Max will create this FPIC. But you can't really do much with this. It's not a button you can click on. But if you load an image in as an FPIC, you'll see its file path will show up over here. And I can just copy this file path and I can delete that object. And I can now paste that in to my image files. So that's going to go in there. And then the none. So at the moment, there's nothing for the second one. If I click this, there's nothing there. In fact, this is the opposite way around because I want the high pass to be when it's on. So I'll just go and grab the low shelf icon. I'll copy that across. And I'm going to delete this none. And I'm actually going to paste this image before the high pass image. I've got to put inverted commas around the file path and a space between them. And there we go. Got my shelf in there. So that switches between the two. Another reason why we use SVG files here, there's two kind of useful things. So first, this SVG view box. When you have an SVG file, there's the icon itself, but then there's also space around the icon. There's like this white space. By default, the icon is just going to fill up the whole height of this object, but that looks a little bit cramped. So I can go here and just say use SVG viewbox, and you see it's kept that space around it, which just looks a bit nicer. The other thing that makes SVGs very useful is you can change their colors. So if I say remap SVG colors, then the colors of those icons is going to follow the colors that I set here. So for example, if I say this text icon off, if I make it blue, you can see that that little icon over there is now blue. So by using SVGs, you can have it follow along with the themes as well when you change your patches. Also, the benefit of SVGs is SVGs stands for something called a scalable vector graphic, which means you can scale it or zoom it to any size without pixelation. So I could take this button, I'll just make a copy, and I could make it huge, and that is still perfectly crisp and clear. And the reason that's important is because if you remember inside of Live, in your preferences, you can change your zoom level. So if you want your interface to kind of always look the same and not get pixelated when you zoom, then it's recommended to use SVG files. Cool. So there I've got a nice little icon in there, which is pretty handy. Let's add in the last part of our patch here, which is this going to be this little toggle, which toggles between like analog mode and just a digital EQ mode, because maybe we want to turn that on and off. So this is going to be a very simple part to add to the patch. I'll make this full screen. We need to use, essentially what we're going to do is we want to have two signal paths here. We either want to take the signal just straight out of the EQ, not through the overdrive, or we want to take the path that is after the overdrive. So we're going to use an object called selector tilde. And the selector just assigns one of several inputs to an outlet. What we need to do is we need to add an argument to it, which is the number of inputs that we want. We want 2 inputs here because we've got just either the clean or the overdriven signal. And then this first inlet is what's going to toggle it between the two. That's where our switch is going to go. So what I can do is I can take the output of the cascade is going to go into input number 1, and the output of the overdrive is going to go into input number 2. And the selector is going to go over there. So this is just going to let us select between those 2 inputs. And I will do the same over here. Set that up. There's definitely some tidying up that needs to happen to this patch, but we'll hook that in there. Oh, not in that one. Hook it into that one. And then lastly, we need another live.text, which is going to be the button that's going to toggle between these 2. Now, the way that this selector works is it opens the inlet of the number of the input. So this is input number 1 and input number 2. So when I send it a 1, it's going to get this signal. When I send it a 2, it's going to get this signal. But if you remember, our buttons send 0s and 1s, not 1s and 2s. So all we need to do is create a new object that is a +1, and that's just going to add 1 to this value. So instead of getting a 0 and a 1 out of this control, we get a 1 and a 2 to switch between those 2. And I hook that into the selector. Let's just configure something about this dial. This is going to be analog. Let's say analog. Short name's also analog. We'll say off and on. The initial, we'll set the initial to be on. We want it to be analog by default. It's kind of cool. And we'll come back to the pictures. We could just use texture. We could just say off and on, but it's much cooler to use pictures. So we'll use pictures. I'll go over and I'll copy this analog SVG icon that I have. And I'm actually just going to use the same image for both. So I'll just paste that in twice. I'll say remap SVG colors and use SVG viewbox. And there I have this nice little icon in there. Last thing I need to do is add this to the presentation. And I can stick that right over there. I could resize it or make it a bit smaller if I wanted to. Save that. And now we can test our patch. So let's try this out. Let's see if all the controls work. In fact, I'm going to save this patch and we'll close it now. One thing that you need to remember to do before saving a patch, generally you don't have to do this, but it's a good habit to lock your patch before you save it. But a very important thing to do is what's called freezing your patch. So when you're making a max patch, if you're using external files, so for example, for these icons, I've used external image files. You need to collect those files into the max patch. If you're familiar with collect all and save in Live, where you collect your samples in, freezing a max patch is the same thing for that. Because if I wanted to share this patch with somebody else, if I didn't freeze it, they obviously don't have those image files. So then these will just show up blank, which is not ideal. So all I need to do is I just need to hit this freeze control and then save the device. And Max automatically copies any dependencies like image files, or if I've used any other external files, into the Max patch. So just out of force of habit, I always like to freeze the device before I save it. And then we can quit Max and let's give it a try. So we can hear, if I don't have my analog mode, this input does nothing. If I turn this on, it's nice and crunchy. That's pretty cool. Switch between my modes. Got a shelf. Amazing. So everything's working as we expected it. So that is our Max patch. Let's take this, open this up and just have another look inside. Cool. Here's our analog style EQ. Now, this is a little bit messy, and there's a couple sort of improvements that we could make to this patch to tidy it up a bit. A couple other things as well. You notice, obviously, when my analog mode is off, the input gain actually does nothing. So I probably want to do the same thing that I did with this gain control over here, where when the analog mode is off, maybe the input gain control is disabled. So I could set up something similar like this. So what you'll see is if I open this version here, which is the version that I built before, and take a look at this, this is pretty much exactly the same patch, but we've got a couple additional things in here that are just worth sort of pointing out that are useful. This selector object that I just added, it's got this attribute called ramp time. Different objects have certain attributes or things like settings that you can add to them by typing an @ symbol after its name. So when I'm adding a selector, if I type @ you can see I have this thing called ramp time. I didn't add that into mine. This is just like a nice little extra thing. What the ramp time does is when you're switching between the two modes, without ramp time, it just instantly jumps between on and off, which can, again, add those kind of clicks and pops. Whereas if you add this ramp time attribute, it smoothly fades between the two inputs over this time over here. Again, this is something that you can always find by going into the inspector of an object, going to the reference, and you can see here it has this ramp time setting, which you can set. The other thing that you'll notice about this patch that I've got here is I've kind of, for like organizational and sort of tidy sake, separated out all these different sections of my patch. So I've obviously got the whole kind of input chain with the analog stuff going on over here. But then here I've got those low frequency controls. Here I've got these high frequency controls, these mid controls, and they're all just kind of nicely and neatly separated. And they're not actually directly connected to the main part of my patch. So Max has these things called send and receive objects. And you can create them either by typing send or by typing just simply an S or an R. And you'll see that there are, if I type send, there's both an audio version and a data version, a non-audio version of both send and receive. And then you give it a name. So if I say send test and I say receive test, Max will wirelessly pass messages between those two objects. So if I hook this up, you can see that data is getting sent without a patch cable. And this can be really useful for keeping your patches tidy because you don't have to have cables going everywhere. You can just use these send and receive pairs to send things to different locations. I like to just give the same send and receive pairs different colors so you can sort of at a glance see where things are going because obviously you don't have those patch cables. So that's pretty useful. The other thing that's really important about these is the way these send and receive objects work is they actually work across different patches. So if I had a totally separate Max patch that also had a receive test object, it would receive the messages coming from this dial. So that can be really cool because sometimes you want to send messages between patches. But where this creates a problem is if I have two copies of the same patch, let's say I've got two of the same EQ on the same channel, and they both have the same send and receive objects. If I adjust a control in one of the devices, it's going to adjust the settings in the other one because it's wirelessly sending those messages, which I don't want to happen. So Max has this thing that you can do where you add 3 dashes before the name of a send or receive object. And what this does is every time the max patch is loaded, those 3 dashes automatically get replaced by a random number. So it'll be 756 test and 756 test. So each different device has its own unique set of send and receive objects so that it's only going to send messages within that particular patch. And so you need to do that on both the send and receive pairs. But generally, send and receive objects can be really useful for kind of tidying up your patch or for sending messages between patches if you want. So you see I've got that in a number of different instances. Like here, for example, I've gone and set up that enabling and disabling this input control when I toggle this, but that's just sent wirelessly using this send control. The other thing that you'll see in here, and this is the version of the patch that you'll be able to download, is I've used things called comments. If I just hit the C key, that creates a comment, and I can type anything that I want in here. You can obviously add these to the visual part of your patch if you want to add labels to different things, but comments can also just be used inside your patch to either for yourself or for other people who might go into the patch, just annotate different areas of your patch. Generally, I kind of recommend using these as you go, because quite often you might work on a patch, then not work on it for a while and come back to it later, and it can be useful to just remind yourself what different parts of the patch do. So using comments throughout your patch can be really useful. One other thing that's pretty important that we didn't add to our patch that we've got in this one is this thing called live.banks. So if you want your max patch to be compatible with the Ableton push, you need to add this live.banks object. If you don't add that, your device will just show up blank on the push. You won't be able to adjust any of the controls there. But if you just create this live.banks object, you don't need to connect it to anything, then you can lock your patch and double click on it, or just hold Command and double click on it. And it opens up this window where you can add parameter banks for push. So you just add a new bank, you give it a name, and then you can add, well, you've got to put it in inverted commas if you want to have multiple words. And then you can choose from the parameters that are available in your patch to add those two banks on the push. So if you have an Ableton push, just remember to add the live.banks object to your patch. Just to close out this thing, the resource pack just reminds you this patch is in here. So what I would recommend you do is download that resource pack and try and start off by seeing if you can just build this from scratch. See how much you can remember. I know we covered a lot of information. You're definitely going to have forgotten some of it. See how much you can remember and try and build an EQ from scratch. Just maybe look at the interface. Don't even open the device and say, okay, what do I need to do to rebuild this device? See how far you get. Then open up the patch and just look and see what's inside there and see if you can kind of figure out what's going on and recreate what's happening. And then obviously go and watch back through the recording and see what you can do and try and rebuild it from scratch. But definitely I find trying to do things yourself first and going as far as you can go until you get stuck, and then going back and referencing a patch is a good way to learn and try and sort of problem solve it yourself. Think about it logically. If I did this, what would happen? So go in and obviously feel free to use this patch in your music making as well. Yeah, you can sort of dive in and use that and explore this patch as a guide. And then start to do that with patches that other people have built as well, because it's a really good way to learn how to build different components and different things, is looking at somebody else's patch and seeing a little bit of the patch that maybe you think, oh, that's kind of cool what they've done there. I can use that in one of my own patches, and learning that way. So